I'd like to go over perfect squares a little bit. If you can recognize perfect squares, then you can factor them right off the bat. Save yourself some time. So let's see what a perfect square looks like when it's FOILed out, and that'll help us know when we can factor it back into a perfect square. Well, if you FOIL this, this really means a plus b times a plus b. So we're going to have an a squared, a ba, and ab, and b squared. In real numbers, ba equals ab, so we end up with a squared plus 2ab plus b squared. So notice we have the first squared. Here's our first, the a. Our last squared. And this is double the first times the last. So if you see something that looks like that, it might be a perfect square. Well, it will be if it follows it exact, but keep your eye open for that. Real quick, let's use what we just did to FOIL out 4x minus 5 quantity squared without really FOILing it. So first we're going to have the first part squared. At the end we're going to have our last squared. And in the middle we have double the first and the last. Hopefully you'll be doing this enough times it'll be second nature after a while. Square this, we're going to get 16x squared. 2 times 4 is 8 times negative 5. So we're going to have negative 40x, and then negative 5 quantity squared. Better be a positive or else this isn't a perfect square. On these next problems, we're going to ask ourselves, is it a perfect square? And if it is, we're going to factor it. So here's our first one, x squared plus 16x plus 64. 64 is a perfect square. In fact, it's 8 squared. So that's a clue this might be a perfect square. Our first one is just our x. So if we took x times 8 and doubled it, do we get 16x? Yes. So this actually is x plus 8 quantity squared. It is a perfect square. And if you are not sure, FOIL this back out and check. Let's do another one. 9t squared minus 12t plus 4. So let's look. Is this something squared here? Yes, it's 2 squared. 9t squared, that is 3t quantity squared. Now if you take 3t times 2 and double it, you're going to get 6t doubled, which is 12t. However, we have a minus 12t here, so this isn't going to be a 4, it's really going to be a negative 2. Technically, we could actually have a negative 3t squared instead of the negative 2 squared. Traditionally, it always goes with the constant. Now, if we double the 3t times the negative 2, we do get that negative 12t. So this is 3t minus 2 quantity squared. So yes, this is a perfect square. And let's try one more. Z squared plus 121. Now this is 11 squared. However, what are we missing? That middle term. We would need a z times 11 and doubled it. So we would need a 22z in here, or a negative 22z, to make this a perfect square. So there's no middle term.